Hello everyone. So we have almost come to the end of the course summary. So this is one of the last topics, linked lists, stacks and queues. So what are basically linked lists? They are an abstract data type and a type of a list, as you can see here, which a singly linked list is a one where each node consists of two values. The one is the data stored in it, and the other is the address of the next node. So the address of the next node points to the next node, and the next node again stores the address of the next node, and it points to the next node. So like this, the linked list continues, and the last node, the address part of the last node is null, and that is where the linked list ends. Now the data part can have multiple things. It can have just a single value, or it can be a structure or anything. So the way to implement the linked list is to have a self-referential structure. So as you can see, this is a structure which is defined as underscore node, and this has one data of integer type and another structure of node type itself. So it is more like a recursive thing. It is a self referential structure. So it is has a the structure itself has a structure of itself, and which is a pointer uh, to it. So the pointer is named next. So this basically stores the address of the next node, which would be again of the structure node type. Now we have created a variable node of the above structure, and then we have also created two pointers, head and p, of the structure node, and then we have malloc the head with the size of node, and we have initialized the data of head to 3. So this is the first node in our linked list. Now we have initialized p with head, so both are pointers, so this is a valid statement, and we will now keep head fixed and move p to navigate down the list. So for int I equal to 1 to 3, we have taken 3 nodes in the list. So the next of p, so this address value of p has been alloc has been malloc to the has been malloc, and the address value of p stores the address of the next node. So the next node has been malloced here, and the address which was returned by the malloc function has been stored in p's next. After that, we have done p equal to p's next, so it advances p by one node. Then we have set the data of p, which is now the second node, to some arbitrary value. We have used 2i plus 3 here. So that's it. And then finally, when this loop is over after 3 nodes, we have set the next of the last node to null. So that is terminating the linked list. Now we will try to see a few operations on linked lists, like inserting a new node. So suppose this was a linked list here, and the connection was from this node to this node. We need to introduce this node in between these two. So the thing we need to do is change the address part in this node to the address of this node, and change the address and initialize the address part of this node to the address part of this node, to the actual address of this node, which was stored in this cell of this node. So what we can do is, so this is the insert function, and here what we are basically doing, we are taking input the position at which we need to insert the new node and traversing to that position. After getting to that position, we are using we get to that position by using p to p next, and using the while loop, and finally when we are at the position, we malloc the new node which we need to insert and store it in t which is again a pointer of node type. So the value of t we change to whatever value we want to put in there, and t is next we initialize to p is next. So here we can see this, if this is t, so t is next is this one, this cell, and we initialized it to p is next. So at this moment this link is still not broken, and p is next points to this address. So t is next is assigned to this address, so this link is formed. Then we use p is next equal to t. So now this link has been broken and this link has been formed. So p is next has become equal to t. So the insertion has been completed and we return the list. Next we have stacks. So stacks are a special type of data type, so data structure, which is last in first out. So it is basically like a stack of books. So whenever we push in the books, so it forms a stack, and whenever we need to take out the books from the stack, we take it out from the top. So the last one which went into the stack was D, and when we are trying to take it out, so it is the one which gets out first. So last in, first out. So basically there are two important functions in the stack, that is push and pop, and the top element represents the head of the list. So we can use this using linked lists or arrays. We can implement this stack data structure. So basically the insertion in a stack is only possible at the top, and also deletion in the stack is also possible at the top only. So this is a kind of a restricted linked list which we call stack. Also you would recall that in recursions we said that the recursive functions use an implicit stack. So that is one application of stacks. Next we have queues. So these are first in first out data structures. So in queues we have two important functions which are enqueue and dequeue. So it is just like any queue in front of any ticket counter. So the one who comes in the queue at first uh, gets a job done and leaves first. So the first one coming in is the first one going out. So these queues can also be done using arrays or linked lists. So the basic thing in a queue would be that the insertion in the queue can only be possible at the rear, and the deletion in the queue is only possible at the front. So front and rear would be two pointers you would require for implementing queue. Also another thing in queue is circular queue. So in here the last, suppose we are using a linked list, so the last rear is uh, point is has a address value not null, but it has been uh, assigned to the value of the front node. So like this the circular queue is complete, and we can identify if the queue is empty by seeing if front equal to rear, then and equal to 0, then we say that the queue is empty. Like the queue starts filling in like this. So first data goes in 0, then next data goes in 1, then 2, then 3, then 4, and finally the queue reaches 7, which denotes that the queue is full. So basically what we need to check is rear plus 1 mod size equal to front. So suppose rear is at 7, front is at 0, size is equal to 8 here. So 7 plus 1, 8, mod 8 would be 0, so the queue is full. Similarly, when rear equal to 1 and front equal to 2, it is also full. So insertion again occurs at the front and deletion occurs at the rear. So that's it. Thank you.